Question 3 on the retake review is similar to question 22 on the Unit 2 test review. So I'm going to go through that question. In your notes, this is like lesson 6, example 2. And so like the previous problem that we did in the videos, it's something when I see completely, it means I'm going to have to factor something more than once probably, maybe using different methods. And so we always start with greatest common factor to see if there's something that I can factor from each of the terms. And so I have something that's quartic right now, but there's no common factor and there's no x term on the last one. So I can't factor this. Remember that every time I have a trinomial, if the highest power is even, then I can still use a product sum chart or magic x. And I can use magic x, not star, because a is 1 here. And so when I'm doing this, I'm doing a times c still, so 1 times negative 45 means I want two numbers that multiply to negative 45. And in this case, they're adding to negative 4. Okay, so I want to find two numbers that multiply to negative 45 and add to negative 4. And so remember, strategy-wise, we should essentially be going through all of the numbers in our list. So 1 and 43. In order for my answer to be negative, the bigger number would need to be negative. And so notice that's going to be negative 42. So that's too big. We talked about 3 and then 15. 3 minus 15 is negative 12, so that's still too big. Again, this is the same number as last time, so we've got also 5 and negative 9. And so notice that that's going to give us the negative 4 that we need. So that means that our two values are 5 and negative 9. What changes with this and a regular quadratic is that normally, if that was x squared, we would write our factors as x times x. Because it's x to the 4th, these two factors are x squareds. So that means that we have x squared plus 5 and x squared minus 9. What we want to do is look at each of our factors now and check to see if I can factor them more. So for both of these, a is 1 and b is 0. Okay, so when I'm doing this and thinking about two numbers, I really will only have something that can factor if the constant is a perfect square. And so this one it is, so this 9 I should be able to factor, and if I'm subtracting it. Okay, so if I have a difference of squares. So remember that the pattern with difference of squares, if I have a perfect square minus another perfect square, then the factor is, I take the square roots of them and I add those two numbers, then I subtract those two numbers. Oops. So if I have x squared minus 9, that means my factors are x plus 3 and x minus 3. So the complete factorization of this is x squared plus 5 times x plus 3 times x minus 3.